Today we are going to be using Snatoms to recreate ethyl enoate. Now, the case number for this molecule is going to be 140-88-5. It has a molecular formula of C5H8O2 and a total of 2 degrees of unsaturation, which we can also see supports the molecule with 2 pi bonds. One functional group that we can find in the molecule as well will be ester. And the total molecular weight for ethyl enoate is 100.1 grams per mole. It has a melting point of negative 71 degrees Celsius and a boiling point of 99 degrees Celsius. So at 25 degrees Celsius, the physical state of ethyl enoate is going to be liquid. And in total, we have 12 sigma bonds and 2 pi bonds. And we'll get more into hybridization and classification later on in the video. As you can see, the Snatoms kit has all the molecules you will need to build any organic structure. Today we are going to use our carbon, oxygen, hydrogen molecules and their respective bonds to build our structure of ethyl enoate. So in order to build our molecule, we're going to start with our first carbon from the very left, and that has 2 hydrogen molecules bonded to it, making it a methylene. And as you can see here, the Snaps model kit comes to its name as is easily snap on. And next we are going to have our double bonds put onto the carbon, and this gives it a trigonoplanar geometry. As you can see here, this snaps on, and that's our first set of double bonds. And now we are going to add our second carbon right here. And as you can see, they perfectly come together, come apart, kind of like puzzle pieces in a way. Now, the second carbon is going to only have 1 hydrogen, and that's going to make it a hydrocarbon. And it will also have a trigonoplanar molecular geometry because of that double bond, the hydrogen, and now the third carbon we are adding. So now with this third carbon, we are going to add our second pair of double bonds. And we're going to start forming our functional group, the ester we talked about earlier. So slide that on right there. And once you maneuver it a little bit, you can see it coming to like shape and form. So now add that oxygen on top. Yep, and that will form the top part. And with that oxygen on top, the ester, the carbon 3 is going to form another trigonoplanar because, as you can see, that double bond on top with the oxygen, the carbon to the side, and now our second oxygen bond. And as you can see there, we are pretty much almost halfway done, and they're looking pretty well. That second oxygen will now have a bent geometry because it's bonded to 2 carbons on each side, and it has 2 lone pairs, which are invisible on top. Now adding that fourth carbon, it's going to be a methylene because once again it has only 2 hydrogens, and it'll have a molecular geometry of a tetrahedral because of those 4 sigma bonds. As here our final carbon, and it's going to be a methyl because it has 3 hydrogen bonds, and is also a tetrahedral because it also has 4 bonds connected to it. And that's going to complete our structure of our ethyl enoate. This is our product from all sides, and I hope you enjoyed this video on how to create ethyl enoate.